Hey everyone, today we're going to be talking about topic 1.4, mixtures. This is a bit of a smaller topic, so there's not as much content to cover here. I had mentioned before that oftentimes we're going to be seeing a lot of these diagrams here shown on the right. What we should be able to do after this unit is be able to tell in these diagrams here what is a mixture, what's a pure compound, in a multiple choice question. So for example, in this one here, if we go through each one of them individually, in letter A, we have atoms of element X as well as atoms of element Z, right? Those atoms of element X are on their own, and in Z, they're in a diatomic. Clearly, this has one or more substances with a variable composition. And so in this case, this would be, I'm actually going to do this with a green one. This would be a mixture. If you go over to B, right, all of them, they have two different elements, right, X and Z, but they're all bound in exactly the same way, and there aren't two different versions of element X and element Z. And so in this case, this would not be a mixture. If we look at C, we have diatomic molecules of atoms of element Z. So this would also not be a mixture here. That would be a pure compound. And if you look at D, you have a mixture of this molecule right here, as well as element X on its own. And so in this case, A and D would be our mixtures. Here's an example of a problem that you might get on regarding mixtures. A 2.4 gram sample of a mixture of calcium chloride, CaCl2, and sodium chloride, NaCl, is found to contain 0.12 grams of sodium. And what we're being asked is the percent of sodium chloride in the sample, right? So we're given the grams of calcium chloride, and we're given the grams of sodium. And so there's a few steps that you want to take whenever you're doing a problem like this to figure out the percent of a particular salt in a mixture. First, you want to convert the element to moles, right? And pretty much with any problem, whenever you're comparing grams of a sample to grams of another sample, whether or not be pure samples or mixtures, you always want to be converting to moles. And so in this case, you want to convert first the element into moles. So our element here is sodium. So we'll take 0.12 grams of sodium times, and we'll divide it by the molecular weight of sodium, which is 22.99 grams per 1 mole of sodium. Grams and grams cancel out. We end up with 0.00522 moles of sodium. And we will look at significant figures later on. Secondly, we want to find the number of moles of the compound, right? And so in this case, the compound that we're interested in is this sodium chloride right here, right? Because we're looking at the percentage of sodium, not the percentage of calcium. And for a problem like this, it's quite simple. You'll take the number of moles of sodium, which in this case is 0.00522 moles, and multiply it by the ratio of regular sodium to the ratio of sodium chloride. So in this case, right, it's a 1-to-1 mixture. You have 1 mole of sodium per every mole of sodium chloride, right? Because we don't have a subscript in front of that sodium there. And so in this case, it's 1-to-1. The answer here is 0.00522 moles of NaCl. Right? If we had a different subscript in front of that sodium, what we would do is multiply it by that ratio. 3, you want to find the mass of the compound. Again, in this case, sodium chloride, and you would just multiply it by the molar mass. So 0.00522 moles times 1 mole NaCl. Above that, you have the molar mass of NaCl, which is 58.44 grams. Moles of sodium chloride cancel out with moles of sodium chloride. We should be left with grams of sodium chloride, which is 0.35 grams of NaCl. So now we have our grams of sodium chloride, but remember we're being asked for the percent of sodium chloride in the sample. And so step 4, which if you remember from a previous topic, we find the mass percent, which the formula for that is mass percent is equal to mass of X, whatever you're interested in this case it's sodium chloride, over the total mass, times 100% to get our percentage. Right, and so we just calculated, I'm going to highlight this in blue, we just calculated the grams of sodium chloride, and we have the total grams of the sample right there up top. And so we just plug and chug into this equation. Mass percent of NaCl is equal to 0.305 grams NaCl divided by 2.4 grams total. For total, I'm just going to put T, but grams and grams cancel out. This times 100%, my apologies. What we get here is 12.7%. And if we look at our significant figures, right, we have 0.12 grams of sodium chloride and 2.4 grams of the total sample mixture. And so we should only have 2 significant figures in our answer. And so our actual answer, which I'm going to write in red, is 12%. And so that is how you would find the percentage of sodium chloride in a mixture of sodium chloride and calcium chloride. Here's another similar example to what we just saw in the last slide. In this case, a student is analyzing a 10.00 gram sample of a mixture of copper and aluminum by reacting copper with nitric acid, HNO3. So they determine that this reaction produces 0.10 moles of copper nitrate, CuNO32. And if they're telling you, assuming that all of the copper in this mixture completely reacts, what is the percent of copper by mass in the sample? So once again, what we're looking for at the end of the day is a percent mass. This is a percent mass question right here. And so unlike the previous question, in this case, we're given the number of moles directly. And so if we go ahead and do the math to find this, what we can do is first take the number of moles we're given, 0.10 moles of copper nitrate. Right, that's what we're given. We want to know the number of moles of copper in the sample, right? Because we're not interested in copper nitrate, we're interested in copper. So we could multiply by the molar ratio of copper to copper nitrate. So we have 1 mole of CuNO3, 2. Now remember, this subscript 2 is only for the nitrate, it's not for the copper. In this case, we only have 1 copper in copper nitrate, and then 1 mole of copper metal. Then we can just multiply by the molar mass of copper, which is 63.546 grams of copper per 1 mole of copper. And once again, anytime we're doing these kinds of problems, you always want to make sure your units are canceling out. That's why I always write out, or at least sometimes we'll write out the element, right, or at least the molecule right here. And so moles of copper nitrate cancel out with moles of copper nitrate. Moles of copper cancel out with moles of copper. So our answer in this case will be in grams of copper. And our answer here is 6.355 grams of copper. Now, of course, we're not done. We want a mass percent. And so we'll just use our mass percent calculation. Mass percent is equal to mass of copper divided by total mass times 100%. So here we would have 6.355 grams of copper divided by the total mass, which we were given, is 10.00 grams. And this is equal to 63.55% copper. So after this reaction, we have 63.55% copper by mass in our sample. Once again, we can't forget our sig figs. Here we have 4 sig figs, but in our number of moles, we only have 2 sig figs. And so this should be rounded to 64% copper. That would be our final answer right there. We'll have a little bit more practice with this in class, but for now, that's all. Thanks, guys.